For this given problem, we are given with circle R, and we are asked to solve for the values of the variables x, y, and z. In order for us to solve this, we need to first identify the figures or the representations of each of the variable and probably look into consideration later on how do we relate it together with the given measurements. X here is this arc from this point to that point. Y is what we call as the inscribed angle intercepting arc X. It is again considered as an inscribed angle per definition that this angle represented by Y has its vertex here as a point on the circle, and its sides are considered to be chords. This is also true with the angle here represented by Z. This is also considered as an inscribed angle intercepting the arc which measures 50 degrees. One thing we also need to note that one of the sides of the angle Z is considered to be the longest chord of the circle R, which is the diameter. Now, to solve for these given variables, we need to first look into the reality that if this is really a diameter or the longest chord of circle R, it divides the entire circumference of circle R into two equal parts, what we call as semicircle from here to here and another semicircle from here to here. What is actually beautiful about understanding semicircle is that it could help us solve the variable x here, since the semicircle measures exactly 180 degrees. That's half of the entire circumference. This would mean that if we're going to sum up this arc, which measures 95 degrees, the value of x, and this remaining minor arc, which is 50 degrees, they must sum up to 180 degrees. In that case, we could write x plus 95 degrees plus 50 degrees must be equal to the measurement of a semicircle, which is 180 degrees. With this equation, we can solve the value of x, which represents the measurement of this arc. And that would be followed with this. You add these two measurements, we will get 145 degrees is equal to 180 degrees. And by use of subtraction property, by subtracting 145 degrees on both sides, we could get an x which measures exactly 35 degrees. This should be the value of the variable x, which represents this arc here. For again, if we're going to add all the measurements of the three, they must sum up to 180 degrees. Going forward, as we look into the measurement of angle y, we need to understand the proper definition of an inscribed angle and its consequence to its measurement. This being an inscribed angle has its relationship to its intercepted arc. For an inscribed angle, or the measurement of an inscribed angle, is half the measurement of its intercepted arc. Again, the measurement of angle y is just equal to 1/2 the measurement of its intercepted arc, which is given as x. Since we already have the value for x, we now know that the measurement of angle y is just 1/2 of the solved value earlier, 35 degrees, which will give you a value in fraction form, 35/2 degrees, or in decimal value, you will have a value of 17.5 degrees. Now that we have cleared the relationship of the measurement of an inscribed angle to its intercepted arc, we could also draw the same understanding as we look further the measurement of angle Z. Angle Z is an inscribed angle intercepting this arc, which measures 50 degrees. Similar to earlier, the measurement of the inscribed angle Z is just 1/2 of the measurements of the intercepted arc, which is 50 degrees. In short, the measurement of angle Z, or the variable Z which represents this inscribed angle, is simply 25 degrees. This is how we solve the values of x, y, and z for this given circle R.